This study is an attempt to explain the processes of consciousness from its most concrete level to its most abstract dimension. We built an orthogonal graphic in which the resulting function is a representation of the easy problem of consciousness. The hard problem is described as the qualia of the process, and we represented it by introducing a plane that is perpendicular to the space-time plane representing the self, scaled according to the Indian sentience scale. According to the Mazio's theory, consciousness emerges through neuronal pathways that involve its mapping and the organism's internal state regulation. These continuous changes generate different consciousness states. Following the retinal pathways determined by the oculomotor nerves, we observe that they present specific characteristics related to the cortical area they activate. Each of them is responsible for inciting a cortical modulation that determines the specific attention directed to the stimulus: autonomic, behavioral, and cognitive consciousness state. The abducens nerve, CN6, holds the object in the foveal area, most densely populated by cones and important for detailed vision of daylight colors. The trochlea, CN4, and the oculomotor nerves, CN3, activate rods, which decode visual signals in low light, generating blurred vision and giving rise to inhibition of attention from the environment. The abducent nerve activates foveal vision and directs attention to the environment. The signal begins in the prefrontal cortex and is connected to the superficial colliculus to the abducent nuclei. This state of consciousness is propitious for the organism to execute movement. The oculomotor nerve signals begin in the inferior retinotopic areas and travel through the Myers loop, following through the ventral stream, which is connected to subcortical areas, the limbic system. This pathway activates autonomic consciousness state. Activated by the trochlear nerve, the signals from the superior retinotopic area travel from the upper bundle to the dorsal stream and the somatosensorial areas. The trochlear nerve pathway is connected to the parietal lobe, giving rise to a cognitive consciousness state. The organism's internal state regulation produces continuous changes that generate different consciousness states. This dynamic is also activated by the eyes through the microsaccades. Microsaccades are small and involuntary eye movements. Current research in visual neuroscience is investigating how microsaccades are related to memory and to attentional shifts. The oculomotor nerve pathways can be represented in a two-directional axis, from phenomenological to autonomic attention. The abducent nerve activates foveal vision and directs attention to the environment. On the opposite side, the oculomotor nerve pathway is connected to subcortical areas, the limbic system, related to autonomic perceptions. Between them, the trochlear nerve pathway activates the dorsal stream areas and mediates both processes, analyzing the external stimuli and the autonomic processes, such as memories, and contributing to image formation. The space-time orthogonal graphic as a representation of the easy problem. The easy problem of consciousness is represented in an orthogonal space-time graphic. The oculomotor areas are represented on the horizontal axis, and on the vertical axis, the time function is represented by the frequency ranges. The resulting function is a curve where conscious processes are represented on the right and upper side. The unconscious processes are represented on the left and lower side of the plane. Horizontal saccades are oriented by cortical processes and elicited the abducens nerve pathway. This consciousness state modulates the mind to focus on the stimuli to enable appropriate action, even when no intention for action is present. Behavior is activated on the prefrontal cortex that directs the foveal vision and fixes locations to extract relevant information for its execution. In this area, three actions are realized. Decision: the dorsolateral prefrontal cortex generates predictive saccades and inhibits unwanted reflexive saccades, contributing to environmental awareness. Stabilization: supplementary eye fields generate voluntary saccades to stabilize conflicting motor programs. And execution: frontal eye field generates voluntary saccades. The abducens nerve CN6 activates foveal vision to scan and fix locations in order to extract relevant information for behavioral execution. This allows the organism to perform a state of readiness for movement. The abducens nerve plays a crucial role in attention priorities, focused on the object's relevant characteristics but always related to action. The quality of information accessed from the environment is limited, but our readiness to act and the objects seen have been shown to allow appropriate actions, even in the absence of any intention to act. The signal travels from the prefrontal cortex to the superior colliculus, through the basal ganglia and the ventral striatum, and by a second pathway through the posterior parietal cortex. The first pathway gives rise to the motivational control of performance, reinforcement, and reward perception, which is felt as pleasant and unpleasant feelings. The second pathway guides gaze movement based on strategic assessment. The autonomic cognitive saccades process memories and internal image formations that are important information sources for behavior execution. This process results in salient stimuli choice. The trochlear nerve, CN4, activates the dorsal stream that builds representations based on stimulus objective characteristics. The dorsal stream decodes information that coincides with stable properties of the stimulus, rather than the temporary egocentric perspectives based on emotions. This pathway generates a state of consciousness that is propitious for responding the question, "What is this?" The dorsal stream carries the seeds of cognition oriented towards strategic mental planning. When the eyes turn down, stimulated by the trochlear nerve, the person is prepared to evaluate the surrounding space, the form of stimuli, and its context. The external world is captured by the senses, which are the body's perceptible limits. The objective is to create an evaluation of environmental variability as well as the body's own perceptible sensory limits. This form of cognition is needed to plan action sequences and to mentally rehearse alternative courses of action. The autonomic consciousness state is activated by the oculomotor nerve that is connected to the ventral stream. The ventral stream has a direct connection to the limbic system and to some autonomic nuclei in the brainstem, such as the striatal regions and the basolateral amygdala. The ventral stream triggers the assessment of homeostatic needs, where the own body seeks to ensure a constant level of functionality for its organs. This pathway generates a state of consciousness that is propitious for answering the question, how does this affect me? This consciousness state activates emotions and feelings. Emotions are the body's reactions to stimuli that occur automatically and unconsciously, activating the autonomic system. Feelings occur after the person becomes aware of such physical changes. Motivation. The person becomes aware of his or her own feelings and seeks information about the organism's homeostatic needs, felt as wanting. Imagination. Feelings themselves tend to be linked to the representation of stimuli through the internal perception of objects. During the sleeping period, consciousness stays in an autonomic state where the body and the mind recover from daylight activities. During sleep, animals and humans alternate between phases. REM sleep accounts for 20 to 25% of the total sleep period and is characterized by the rapid movement of the eyes from side to side. Those REM eye movements are also microsaccades and might be associated with cortical activation rather than to vision activity itself. The hard problem of consciousness, introducing the self as a third axis. The self-axis is scaled according to the traditional Indian sentience scale. Consciousness is a development from a direct stimulus relationship to a stage where the organism becomes self-aware. This is a directed relationship between the organism with the stimulus. This is so, a subtle understanding of the stimulus and a consequent explanation of the experience. I'm affected by this is so. Awareness of how the experience affects me, the self. This is I am affected by this is so. Self-awareness emerges as a higher consciousness state. The resulting graph is a spiral curve running from the cortex to the subcortical regions and back to the cortex again. Even though the cortical substrate is the same, their qualia differ. At the lower levels, the stimulus is analyzed by its physical characteristics, and at the upper levels, the analysis is more abstract and more suitable for symbolic representations, such as mathematics, philosophy, religion, and the arts. In this three-dimensional graphic, consciousness is represented as a wave function, indicating the quantic state of the particle until it's condensed as behavior. This graphic might explain why the wave function can only be understood in a symbolic language, such as mathematics sentences. The hyperconsciousness is also experienced in religious symbols, which represent spiritual experiences, or by artistic images that fragment ideas into symbolic substrates. Thank you.